DDI Central Tech videos. In this video, we'll demonstrate how you can automatically detect, identify, classify, and customize precise configurations for targeted devices using an interesting feature called DHCP Fingerprinting within ManageEngine DDI Central. Let's get started. First, let's explore what DHCP fingerprinting is. DHCP, or Dynamic Host Configuration Protocol, assigns IP addresses to devices on a network. Fingerprinting in this context refers to the method of identifying devices based on their DHCP conversations requesting IP addresses and other network configuration settings in the form of DHCP options from the DHCP server. It's like having a digital fingerprint for every device that connects to your network. For example, many organizations want to have their VoIP phones reside on a dedicated subnet or use a specific DNS domain for secure access and management across the network. To successfully implement DHCP fingerprinting for the VoIP phones, the targeted subnet pool must be configured to recognize VoIP phones and instantly assign an address within the allowed range. In DDI Central, this is performed using a special construct called client class, and this client class is associated with a specific address pool within the subnet. This way, all the VoIP phones joining the network will be assigned IP addresses from the specified range within the chosen subnet. You might wonder why use DHCP fingerprinting. This feature enables network administrators to enhance security, automate device-specific configurations, and optimize network resource allocation. For example, it can automatically identify a new printer and allocate it to the right subnet or apply tighter security policies for IoT devices joining the network. Imagine the time and trouble saved by IT technicians automatically using DHCP fingerprinting functionality in DDI Central. Now let's consider a healthcare use case scenario where DHCP fingerprinting enables seamless connectivity across interconnected private networks connected to provide round-the-clock radiology services with the expertise of multiple subspecialties. Healthcare network infrastructures are so complex that they often involve multiple interconnected remote healthcare sites, clinics, and branch hospitals spread across the country or a region. With DDI Central, we can easily manage the three critical network services, DNS, DHCP, and IPAM of each remote healthcare facility already connected to the main hospital network using advanced technologies like SD-WANs, IP MPLS core connected via VPN, or even dark fiber cables. This way, the hospital network administrators can holistically view and centrally manage the critical network services of different remote healthcare facilities associated with the main hospital, all from a single window. Imagine when a patient with a head injury arrives at the emergency room of a regional healthcare facility at 3 a.m. after a fall and receives a CT scan. While the patient is being cared for in the emergency room, his CT scan is being viewed by a radiologist working from the main hospital. The radiologist needs to consult with a specialty musculoskeletal radiologist who is working at one of the branches of the main hospital. Both radiologists need to view the same study and consult with each other while working from different locations to arrive at a diagnosis for the emergency room physician. Now, both radiologists want to connect their personal computers to the regional healthcare facility's private imaging network, which is typically a private LAN isolated from the public network and connected to it only through firewalls. This private network has its own DNS and DHCP clusters. The facility hosts the web-based software that displays images only to clients that possess the correct IP addresses from a specific range of the subnet 100.100.100.0/24 within the regional healthcare facility's address space. To ensure radiologists have real-time access to the web-based image viewing software, we need to establish client classes that enable the DHCP servers to identify their personal computers by their unique MAC addresses and immediately assign them in an IP address from a dedicated subnet within the private network. Let's create a client class that defines the conditional or matching criteria for the clients who are allowed into the private imaging network of the healthcare facility. First, ensure you're logged into your DDI Central console, navigate to the DHCP module and select the network menu. On the network page, navigate to the Client Class tab, click on the Add Class button in the top right corner of the page. On the Create Client Class page that appears, let's enter the essential details for the client class. Due to time constraints, we've already set up a client class for our special use case, and we'll review its configurations to explore how it successfully identifies the radiologist's devices when they try to connect to the remote healthcare facility. Let's name the client class Radiology Department Members for easy identification. Assign a suitable scope level for the client class where the global option is chosen to be applied across all subnets within the remote healthcare facility. And the subnet option is chosen to restrict the class to a particular network segment. For our current use case, let's select the global scope level. DDI Central provides two methods to define client classes, through user-friendly template forms or by traditional ISC format code. For simplicity, we'll opt for the template method. Selecting the template option will prompt additional fields to display. In the match type, select the substring option to tell the DHCP server to search for a specific sequence of characters within the client's DHCP message. The offset field is used to designate where this search should begin within the DHCP message. Since we want the search to begin from the very first character, let's enter the value 1 for the field. For the length field, input 17, which corresponds to the length of the MAC address, enabling the DHCP server to match the client's DHCP message against this information. Enter hardware in the match string field, guiding the DHCP server to specifically recognize and extract the hardware address from the packet. The conditional statement field enables us to construct expressions with the server-defined functions to examine parts of the incoming DHCP packets. Further details on this are provided in the DDI Central user guide. Since our goal is to match specific MAC addresses, let's navigate to the subclass section and enter each radiologist's MAC address in the match value field under a subclass and click Add after each one. So for each MAC address, we'll be adding a separate subclass match value. Once all MAC addresses for the radiologists across the hospital network are entered, click Save to finalize the configurations. Now the client class we've just created, Radiology Department Members, contains specific rules that match only clients with certain MAC addresses. These special rules cannot operate in isolation to find a match for the clients joining the network. To activate them, we must associate them with the appropriate subnets within the healthcare facilities network. Last but the most important step is to associate this client class we just created, Radiology Department Members, with the targeted subnet. Failing to do so means that the DHCP server will not be able to detect the radiologist's devices when they try to connect to the private network and reject their access to the private network within the healthcare facility. For this, we'll have to navigate to the DHCP module and select the network menu. On the network page, select the subnet tab. Under the subnet tab, open the targeted subnet 100.100.100.0/24 in edit mode by clicking on the edit button in the extreme right end. Now within the edit subnet page, scroll down to the end of the page where you'll be able to locate the pool data tab. Pools in general are used to control the distribution of IP addresses to clients within a subnet. They allow more granular management of IP address allocations, including setting different options or restrictions for different pools within the same subnet. Under the Pool Data tab, we will create and define a specific address pool within the subnet and apply the client class configurations for the IP addresses within that range of the targeted subnet. Doing this will inform the DHCP server that this particular range is available for dynamic assignment and that it can lease out these addresses only if the clients satisfy the conditional criteria as defined in the client class associated with the address pool. To implement this, click on the Add Pool button in the extreme right corner. So on clicking the Add Pool button, we'll get to see the Add Pool window. Here you can define the address range by specifying the starting IP address as 100.100.100.2 and the ending IP address as 100.100.100.250 of the new pool within the chosen subnet, and click the Add button in green in the right end after each entry. So due to time constraints, we've already set up the client class configurations here. We'll quickly review the configurations required for a special use case in edit mode. Now in the edit pool window, we can see that the designated range has been defined. For the allow option, the address pool configurations within a subnet can either allow or deny specific client classes for dynamic IP provisioning. Choosing none means the address pool is open for dynamic provisioning to all clients joining the network without any restrictions posed by any client class rules. If the allow option is set to yes, the pool permits dynamic provisioning of IP from the chosen range for the client class rules we specify on choosing yes. So here we've chosen radiology department members. On the other hand, setting the allow option to no excludes provisioning of IP addresses from the chosen range for that client class we specify subsequently. Click Save to preserve these pool configurations, and then again click Save to preserve the updates to the targeted subnet. Now let's take a different subnet, 172.65.43.0/24, from the Regional Healthcare Facilities private network. As this specific subnet is intended for other critical services within this healthcare facility, we will want to exclude it from being assigned to our hero radiologists who are already dedicated to a vital medical case. To implement this, select the subnet from the network page and open it in the edit mode. Navigate to the Pool Data tab, and let's repeat the same procedure like defining the address pool range as 172.65.43.99 to 172.65.43.190. For this range, let's select the allow option as no and select the client class subsequently as radiology department members, and save the pool configurations and then the subnet configurations. With these configurations in place, the DHCP server will never assign the IP addresses within the defined address pool to radiologist species joining the network when it spots the specific MAC addresses as specified in the client class radiology department members. Now this precise allow and deny setup ensures that the radiologists can securely and efficiently access necessary resources from various locations, thereby enhancing the delivery of critical medical services. Finally, the hospital network administrators utilizing DDI Central can verify the IP addresses automatically assigned to the radiologist's personal computers by accessing the lease menu under the IPAM module. First, let's navigate to the IPAM module and then let's select the lease menu. Here, they can select the relevant subnet, say 100.100.100.0/24. They can review the leases and note that the MAC addresses of the radiologist's computers have been allocated IP addresses within the range 100.100.100.2 to 100.100.100.250 by the DHCP server for a specified lease duration. This demonstrates that the DHCP server, following the client class policies, has permitted only devices with those specific MAC addresses to access the private subnet 100.100.100.0/24 and has allocated IP addresses within the designated range. In this video, we walked you through setting up DHCP fingerprinting using ManageEngine DDI Central, starting from understanding the concept to actually configuring client classes for specific network needs, like in our healthcare facility scenario. Remember, the true strength of DHCP fingerprinting lies in its ability to not only automate the assignment of IP addresses based on device type, but also to enforce network policies that bolster security and improve performance. By defining precise client classes, you ensure that each device connects with the right configurations and permissions tailored to meet both its operational function and the security requirements of your network. And this marks the end of the video. Thank you for watching. Dive deeper into the world of DNS, DHCP and IPAM with us and discover how to use DDI technology to streamline your network operations. Don't forget to like, share and subscribe for more insightful content from DDI Central.